welcome to this session. I'm very sure you are in the right room at the right time for this session. There we are going to talk about enhancing forecasting and observation data and applications for the dryland. I will be your moderator for today. My name is Maureen Amani. I work for the World Food Program. I am based here in Nairobi, and I coordinate work on anticipatory action in Eastern and Southern Africa. So thank you very much for taking time to come for this. Should be a very interesting session. What we'd like to do today is to do a mix of presentation and discussions with you. We would like this to be as engaging as possible. Hopefully not to do that by PowerPoint, even though we're still going to have some PowerPoints, but we are hoping to engage you quite closely throughout the session. Just so that we can keep ahead of the time, I'm going to start, and we'll start with engaging you. And this is a photo that was taken in the Somali region of Ethiopia 2 weeks ago, 1 week ago. And I'd like you to look at the picture for just a few seconds. And as you're looking about it, consider this. The current seasonal forecast is saying that in Somali region, as well as in parts of Kenya and parts of Somalia, the coming season is going to get below average rainfall. The coming season, that is October to December. Now, considering this and looking at this photo, what kinds of information or data would you want from our observations such that it can inform action? We'll give it a pause for you to have a look. And I'd like to hear reflections. What kinds of data or information would you want our observations to give you from this photo such that it can inform action? Anybody want to go? Okay. Thank you.
Is there any biomass to eat?
Very good one. Is there any biomass to eat? All right. Okay.
Forecast on precipitation.
Focus on precipitation, but why precipitation?
I think for dryland could be one of the limiting factors for the whole pastoral system.
Okay, which leads to something in the photo. Okay, we can have a mic here and then there, then we move.
Yeah, we're going to have the data on that water point.
The water points. All right, interesting. Okay, just one more here.
Yes, I'm not sure, but if you have give me this on the market price, I'll be very happy because I can see those animals in very good health condition. So I can take the markets as part of my preparation for the oncoming crop situation.
Okay, I don't know if you guys already looked at the presentations that are coming up, but it's very interesting. These are some of the things that we're going to talk about or present in this session, and we look forward to hearing what comes out of it. Sorry, I know there was a few hands up, but we'll move forward and then we'll still continue to have the conversation. So with that in mind, I'd like to share what happened with the work that the World Food Program did back in 2022. Now, the World Food Program has been implementing anticipatory actions for quite a long time in different places in the world. One of the places is Ethiopia, specifically Somali region, with a focus on drought. Now you remember the prolonged drought that happened in the region between 2020 and 2023. In 2022 specifically, we got forecast information that told us it's going to be another big rainfall season. And what happened is that you can see the boxes here. We had a trigger set up such that we were looking at what happened the previous season with the rainfall, but you're also looking at what is the status, current status of vegetation, and therefore, should we then activate anticipatory action? And based on this trigger information, in addition to the forecast, you can see it here, we actually activated 3 anticipatory actions in Somali region. Dissemination of early warning, giving people some cash transfers, but also some work on rangeland rehabilitation and further production. So based on that, sorry, the slide was skipping a little fast. Based on that, okay. Okay, maybe we just need to do it manually. So based on this information, the action on rangeland rehabilitation, we needed to figure out where would this be done. And you can see the figure on, that would be your left, was the mapping of the area where this was going to be done before the intervention. And then the other figure on your right is the mapping of what happened after the rehabilitation of that particular rangeland area was done. Again, using Earth observations for us to be able to map out the before and after, so that you can also understand what is the impact of the intervention that we did. And you can see this happy gentleman who was showing us the amazing things that he had to be able to, take care of his family as well as the livestock that he had in the Somali region. So this is just a snapshot of the kinds of conversations that we would like to have in this specific session. And to help us move forward, we have a couple of presenters who are going to tell us the amazing things that they are doing with Earth observations, but we would also like to have you do a bit of reflection as you listen to the presentations. So one key questions I'd like you to think about is, are the Earth observation solutions that are being presented, how useful are they for anticipatory action? Is there anything missing that could be added, especially to help us to take action before things become so much worse and a humanitarian crisis emerges? And then towards the end, we will have a wrap-up with 2 panelists. Clinton Obola from the Kenya National Drought Management Agency, I hope he's in the room, as well as Mr. Eugene Kaijamane, who's going to help us to do a bit of a reflection on what we have had. That said, I'd like us to move then to the first presentation from Francesco Fava from the University of Milan, and he's going to tell us about the next generation of Earth observations for anticipatory action in the drylands. Over to you, Jessica.
Good morning, everyone. Very nice to meet you. I'm Francesco Fava from the University of Milan. I'm an environmental scientist, and I've been working on remote sensing application for quite a while, especially pastoral drylands. So, the question, I think probably, hopefully it was. The question we have for this session is how to enhance forecasting and Earth observation data for an application for dryland. Not an easy question to answer. So I thought to propose some of our project and application, but I rather decide to share some reflection, through the reflection that or learning that I have from my own experience. So, well, okay, first. So in the last days, there were a lot of exciting section about the need of action mechanisms, community level, the need of integrate local knowledge, indigenous knowledge to act, to provide a response. But still, I think it's very important not to forget that we need also to have an accurate trigger mechanism. So we need to be able to design Earth observation and modeling applications that are able to predict the impact of our habitat drought. So I want to surprise you in saying that remote sensing technologies has evolved a lot. And we are now able to map different phase of the characterize different phase of the drought progression. For example, we can predict or assess quite well rainfall with meteorological satellites. We can also assess agrometeorological drought to develop transpiration or soil moisture. And we clearly can assess agricultural drought, vegetation indices, and other indices that are relevant to map vegetation condition. And more we can also derive indicators that we will see in the next presentation around socioeconomic impacts. So we have a number of options, data sets and data to consider. But what we don't have open clear is when to use a trigger mechanism for what. So we need to really link this mechanism to the action that we want to trigger. And this is one thing. So another consideration is that we are now talking about anticipatory action. We want to react fast to the shock. But trying to respond early and moving from detection to early detection to forecast means also increasing the uncertainty in our models. So I think we need to recognize that there are trade-offs, and we need to be much more explicit about uncertainty in our models to find the right compromise between a no-regret approach, so acting faster and quickly, but also cost effectiveness to be sure that we trigger the response that is actually needed. And this is a complex exercise. So for this, my solution is we really need clarity on both when designing good products for drought assessment and forecasting. And we also need to have a stronger agenda on quality standards and methodology to compare and assess the quality of alternatives. My second message is around maybe we've been discussing a lot, but the need to connect the scientific progress with the practical implementation. So we need to connect with the community needs and with the operational institutions working in this space better. Of course, we need to recognize that both elements, scientific advancement and good implementation, are needed, and they need to learn from each other in a continuous loop, but not that science deliver and implement. It needs to be a continuous learning exercise. But to do so, we need to recognize also the challenge that when an operational initiative needs to introduce a new technology, they have in terms of changing the whole framework of operations, which is much beyond product design. So we need to be able to be evaluating again the quality of the products and the added value of any technological advance. Otherwise, the risk is to produce something, invest in something that is not relevant overall. So for addressing this challenge, I think that there are too many examples, too much fragmented about initiative, data sets, indices, and more harmonization and joint work between institutions is really needed to co-invest in a continuous agenda around improving product design. Third consideration is around understanding better the impacts of drought. We can derive more and more indicators from observation, but we have no clarity about, in my view, about the mechanism that lead to impacts. And so this example is about crops, but we can easily extend to rangelands. And so we need to understand compound effects, so multiple risks operating at the same time, like drought, heat waves, and how they can trigger cascading effects. For example, soil compaction that is like an enabling condition for flash floods to happen with future rainfall. And this is a major element triggering lack of mortality events. So I think we need to consider this complexity that is described in order to design more effective trigger mechanisms. And this should be also related to short-term and longer-term impacts of drought, which is a slow progress progression type of shop. So for here again, the combination and integration of Earth observation with market asking platform crowdsourcing approach could be very valuable. And there are some good examples of cabinet and the system, ACR system. So I think we are on this path. Last consideration is something that we have been discussing a lot in these days. Okay, we are discussing about how to trigger emergency response, but we probably need to use remote sensing and to think about remote sensing in a much broader way. In the session, so some examples of what we've done, but we need to think also more proactively how we can use remote sensing to better manage rangelands, how we can use this to de-risk the pastoral system, and how can we develop scale adaptive rangeland management and livestock management approach. There are technologies nowadays with last advances in remote sensing, very high resolution data, hyperspectral remote sensing data. We are now doing some research and we are able to map not only the quantity but also the quality, nutritional quality of grasslands. So this can be used and must be introduced to rangeland management approach. I think with this, I'm done. I just want to say I'm not just talking. We are doing several projects that there is a list, and I'll be very happy to discuss with you about the details of all this initiative. And
All right, thank you very much, Francesco. I think you have left us with a lot of food for thought. Please do write down the thoughts that are occurring in Francesco's presentation, as well as questions. We'll take a pause after the next presenter so that you can have a discussion. So like that, I'd like to welcome Anton Gevin for the next presentation.
Thank you very much, Marie. Thank you also, Francesco, for the presentation before. My name is Anton Frieding. I'm from the Faculty of Geoinformation Science and Earth Observation at the University of Twente. Twente is a small region in the east of the Netherlands. The town is called Enschede. And I'm quite happy to see that we have a lot of these. I met several alumni also here in the room. So our faculty is basically all about geospatial analysis, Earth observation. And today I want to present basically on one project that's bringing some of this together, called Range. Range is a project that started last year. It's a 5-year project funded by the Dutch Embassy in Kenya. And we have different partners. So Mercy Corps is the lead. Many people of Mercy Corps are around. FCDC is part of it, Frontier Counties Development Council, and then we are the third part, which is ITC, and then of course also a number of many collaborators. The project is about a number of things, but also we focus also on Earth observation, and in this session I will focus mostly on that part. So there we are. So it's a big project, so we have a lot of goals. We hope to achieve many of them, and maybe many of them not, but at least we have a way to go. So what we want to do is focus on improved rangeland management. I think there's a lot of talks that are already on that today. Also looking at things like alternative livelihood production, competitive markets, and those two goals are mostly related to Mercy Corps activities, although we have linkages with that. FCDC, so they're the economic bloc, so they try or we help different countries in the ASALs to work better together and also to promote stability and sustained development. And as we cannot see the bottom of the slide, I'm not sure what we can do about it. But our focus with ITC is really on the strengthened research and evidence-based programming. So we focus also on early warning and early action and innovation. I think yesterday was a session on innovation. I think we tried to link to that to come up with new ways of doing things, basically, that hopefully help. We have an official project document where there's goals listed, but I just try to reflect it in what do I see as goals, which I think are the most important parts that we focus on. And I think part of our contribution relates to basically the DNA of our faculty as well, that we hope to enhance geospatial capacity also in the countries where we work. Of course, with an idea to help to strengthen pastoral resilience as well. So how do we do that? To some extent by performing relevant studies that to get better evidence of status and trends in the rangelands. So we focus a lot on data. Given data, I mean, part of innovation is also that we are piloting new things. Yeah? So what we want to pilot, for example, is new technologies to get sensor data collection, but also work with partners that are already collecting longitudinal data, survey data, photograph data, to improve rangeland monitoring. And to do it all in partnership as well, not alone. Yeah, it's quite sensitive. Maybe very shortly, what my background personally is, and then I'll link that to the rest. I've been working for about 12 to 13 years, also with the International Livestock Research Institute, related to the ILRI program, the Integrated Livestock Insurance. We've had several papers on that, on how we transform the NDVI data into a triggering index, and there's many ways that can be done. Even with NDVI, you could think of other data sources, but also different ways of integrating information. Problem is always like, okay, in the end, how do we say that something is better than it was before? So what is the data that will tell us that one index, one trigger is working better than another? So I think that is a bit my background where I come from, where we cite a number of studies that should help in that. Very briefly, I think these people are all in the room, and I'm very happy for that. So we have some excellent people from Kenya that are working in the project. So we have 5 PhD students. They're in the room. I see. Well, maybe you want to stand up. Sure. So yeah, feel free to engage more. I put up the topics, but I'll make a bit of a summary later, so you can read at the moment this, and I'll summarize a bit the EO part. What I want to stress here also is that we're trying, and I mentioned that in the previous slide, so we work in partnership. So it's not that we say, okay, we have studies from ITC, this is what we're going to do, but we really try to link into local organizations as well, such as ILRI, IPAD, University of Nairobi. I see Oliver also in the room is closely working with the on PhD research. Let's say the elephant, the USRS. So I think it's very valuable. On top of that, we also have we have a 5-year program, so we have a 2-year master in our faculty, Master of Geoinformation Science and Earth Observation. And here we really have every year we try and have 3 MSc students from the region. So the project, I did not mention it carefully, but maybe you saw the map, it was focused on Isiolo, Marsabit, and Samburu. So every year we have a person from Isiolo, Marsabit, and Samburu that is entering into our MSc program as well. And it will also perform the research here in Kenya together with PhDs and locals. So I think that's part of the capacity building. Furthermore, some of these students, they also come from county governments, but also we want to engage more with county government to help build geospatial capacity at the counties to come up with better informed decisions that are based on data. So you see some initial training sessions that we have. And as I said, we're also working with Garissa University. You can see we have a person from Garissa University here as well, so we're also happy with that collaboration. I think it's the only real full-fledged university in the ASEAN country, so I think it's important collaboration as well. Sorry, I'm not very good in my clicking. Oops. Very sensitive. So just a few slides, and as I said, I will not present a lot of nice maps. Unfortunately, I mean, Earth observation is all about nice imagery and nice maps, but I just want to show what are we going to work on in the different studies. So with Earth observation range, I think the real purpose, as I already tried to say, is that effective decision making requires high quality data on rangeland conditions, rangeland use. So the goal is to improve satellite-based methods, work with satellites, but also in situ data collection. So that's a very important part. So we have some key activities. One is the thing on LoRa one. LoRa one is shown a bit later, but it's a sensor network in which you can connect different sensors that look at racing status, that can look at also animal movement, weather, etc. So we want to pilot it more in the region, but also, so that's part of our intention to set up more longitudinal data collection. At the same time, we work together with ILRI, with NDMA as well, on using their longitudinal survey data to see, okay, how can we better use that to make informed decisions and improve also the satellite-based based monitoring. We want to look at livestock enclosures as a way of better understanding livestock movement. Where is livestock in what season as an idea? So where there could be conflicts, where maybe vaccination campaigns should be held. So that is one part as well that we do. And not important, also we want to enhance drought monitoring. So looking at satellite series that we already do with drought monitoring, but how can we account for the first use and ecology of rangelands? Another thing we want to look at recent, but there's a lot of NGOs and government agencies that are doing restoration efforts, but how effective are they? So can we come up with good data as well to show the effectiveness of past interventions to inform also future interventions? And then lastly, but not least, also we want to make that data available to better inform county level land use planning. Now, Earth observation, both in situ and satellites, are very nice, but I think it's not the only part, and I think we already had many presentations that highlighted that. So I think it's also really important to link to other knowledge. So local knowledge here. So we have people that depend on the land and they have a good knowledge. So let's use that to try to integrate that. So what we want to do here is identify, for example, key rangeland resources that could potentially help to inform also our drought indicators. Now, people, for example, in this case, life insurance is taking a unit and taking the average NDVI of that unit, but what are the important areas in that unit that should be considered? And I think understanding the dry and wet season pastures is really relevant to do that. Look at also local indicators of rates and health, and also get better community perceptions on rates and status and shift in pastoral mobility. I think that Nathan says the time is almost up, so let's try to make it short. Just on LoRa, I think I mentioned that already. So LoRa is basically a section. There's the gateways, and we can transmit at low cost, at low battery cost as well. We can transmit small amounts of information over large distances, and we hope to use that to come up with better tracking, but also better sensor data. And there's one last slide, if you allow me, that I want to just show, just to show some maps. One of the ways there's nice applications currently that's, and I was looking at Maureen's first slide. I thought my immediate thought was I want to know how many animals are there, and detecting individual animals. There are studies that do that. Yeah. I think recently there was a study published about the Nosemana as well, where animals were counted from high resolution satellite imagery. So to some extent, yes, you can see that, but it's like here, for example, we see animals, we see cattle in Boma. But it's hard to scale it over large areas because these data are usually quite expensive as well. So I did want to highlight what we did last week. So last week we were in this ILRI research station in Capiti. We were flying overnight. We had seen many nice sunsets and sunrises, but we were trying to see with thermal imagery, initially with a drone. So what you see here, so we can with thermal imagery can identify thermal anomalies. So to see where there's heat together, and of course, what we eventually want to do is to see there's new satellite images, satellite emissions coming up that can also measure the thermal, because we have many animals together. Can we do it in a good way over large areas to get better understanding of this, these changes in types of distribution. Okay, with that, I want to finish off. And this is just a team in front of our building. Thanks very much.
So we'd like to proceed with the next presenter. And James is going to present to us a very specific solution that they are working on surface water mapping. for use in anticipatory action. And I hope it is one of the solutions that you start to see is answering some of the questions we have in the room. I'm happy for you to also think about what is still missing for this solution to better serve, like you said, the people.
Okay, good afternoon. I'll try to at least try to answer some of the reflections from Francesco and again from our colleague there through what I'm going to present. And here, what we are trying to do is to translate the pixel into a decision. And for this particular purpose, I'll be looking at the water maps for the early action. So my name is James Boboka, a research fellow at the University of Sussex. And I'll be presenting part of the work under the PASSAGE project, which is strengthening pastoral livelihoods in the Greater Horn of Africa through effective anticipatory action. And to try and respond to some of the questions that we have had already, is that we are also working with the practitioners, as you can see from this particular slide, with the partners that we have. Some of them working very close to the communities, as well as some of the actors who respond when hazard strikes. So the question is, why are we here? And as my colleague mentioned, pastoralists look at three things: security, water, and grass. And on this particular presentation, I'm looking at water and looking at the decisions that pastoralists make. He has already begun by saying that they make decisions based on one, which is water. And we are trying to look at how can other observation resolve or try to give information for better decisions for better decisions. And we are looking at this by showing a practical path where a pixel translates to early action triggers. So what we see, and Francesco has already mentioned that, is that other observation has a global or an overview of different things on the environment. And for this particular case, we have high resolution from Sentinel data, which is a satellite orbiting up in space, which provides high resolution data. Again, to try and answer those small scale decisions, we need very high resolution. So we have Sentinel at 10-meter resolution and Planet, which is 3 to 5 meter resolution. They have a high revisit time, what we call temporal resolution, how many times it passes through a particular space in time. So for this particular satellites, currently we are being at 5 days. We also have an additional satellites living in the tropical areas. We have a very big challenge with clouds, and SAR data helps us to be able to look beneath the clouds, to be able to understand what is happening there, and gives us that consistent monitoring. And then there's something we call the spectral aspect of the data, which is how much can be interpreted from that information. And so that gives us a little bit more information to try and help us to be able to deduce information from it. And lastly, how can we be able to scale it up? And currently with technology, we are having solutions, cloud-based solutions that help us to do this quite rapidly and over a bigger area. So how are we mapping ephemeral water bodies? So this is just one particular component that we are implementing within the PASSAGE project. And so we have a component in which we are ingesting EO data, doing feature engineering by deriving indices from those particular satellites. And again, using artificial intelligence or machine learning, trying to deduce the relationship between the various components to try and predict where some of these surface water bodies are. And of importance for this particular case, we are talking about ephemeral water bodies. They are very small and very dynamic. So we are looking at how fast can we be able to do that. And we are producing this for maps. And again, as we say, we need to produce information on uncertainties where we cannot be able to say, well, we are not really sure about that info, about the prediction of the system. And looking at how we can be able to produce this on a monthly basis. So from picture to trigger, so how do we envisage doing this? As I mentioned, PASSAGE is a research project, so it's work that is currently ongoing, and we are looking at tying these particular maps over a duration of time, understanding how those variabilities happen, how the dynamics happen within those surface water bodies, to begin developing actions based on that. And we are doing that, trying to develop thresholds. I believe Maureen had already begun that discussion about the threshold. At what point do we see that we can respond? Can we use service water bodies to make decisions regarding early response for the pastoralist communities? And so we're indicating to do this at shorter lead times. So again, looking ahead, one of the requests from this particular session was, how can this translate into early action? And again, feeling the audience on ground is that we are looking at it at the lowest local level or at the lowest level possible. So we are looking ahead at how can we produce this information at what we are calling nowcast, and also at the sub-seasonal prediction, because we see they are very dynamic. So we want to have pretty short durations of information to be able to make those decisions and at the highest resolution possible. We are thinking about developing dynamic triggers. We know these changes at a time. We are thinking of developing dynamic triggers, again, using these data pipelines to be able to produce this at scale and also at an efficient speed. And also something that most of the time lacks within the other observation is on getting feedback. And feedback, we are saying that the satellites are predictable, the satellite through the algorithms are predicted the changes in the water. Can we get feedback from the ground, whether that is the case, or do we need to further train our model, further tune those models to be able to increase on the accuracy of the information provided? And finally, as Anton had mentioned, is to build capacity such that this information are the people who are the actual implementers or the actual users of this information. I think I will stop at that, but passage is quite looking at a number of things. We are looking at risk monitoring for vegetation, for water, for extreme heats, and working with IFRC, WFP, again, developing early action protocols or developing triggers for early action protocol for the cross-border area. The map represents the cross-border area between Somalia, Ethiopia, Kenya, South Sudan, and Uganda. Because currently we don't have that, but we are trying to see how best we can be able to develop that. Thank you.
All right, thank you very much, James. So far we've had solutions that range from pasture to monitoring livestock movement to water. So I'd like us then to shift to another solution that's been developed that was also raised at the start, that can we know anything about markets? Yeah. So with that, I'd like to hand it over then to Daniel, who's gonna tell us a very interesting approach that they are using Earth observations to monitor rural markets, especially in Sudan, that we know right now is facing conflict. So over to you, Dan.
Thank you very much, Maureen. Hi, everyone. Thank you for coming. My name is Dan Hudner, and I'm a researcher with Mercy Corps. And I'll be presenting a study that we did with funding from Spark, looking at the use of remote sensing and particularly satellite imagery to explore the impact of the conflict in Sudan on rural markets and agriculture. I'm also going to try presenting a live map, so bear with me. It takes a little while to load. The other thing I'll say, and this is, I feel like, a cardinal sin in presenting, you're going to see words, and I would ask you not to try to read the words, just look at the pretty pictures for now. So our study used a variety of data sets, particularly a novel mapping of rural marketplaces that's been developed by Professor Tilman von Karnap at the University of Oslo to explore the impact of conflict on markets in Sudan and on agriculture as well. This is done with two main purposes. First, to help understand overall the extent to which these markets are still functioning, and then coming from particularly kind of the INGO and the humanitarian space perspective, trying to inform targeting and calibration of interventions and aid. I think the targeting is pretty straightforward in areas that are seeing both the decline in market activity and agricultural activity. That kind of speaks to additional need there. Those are often the most conflict affected areas. But then particularly in terms of calibrating and kind of deciding on the type of intervention, we think that this data set and this approach can serve as a complement to other monitoring and research that's being done to help INGOs be a little bit more thoughtful and understanding of how market systems, and particularly the kind of more local rural market systems, are adapting. Because there is a risk that kind of well-intentioned humanitarian aid, so food or seeds being given out, may actually undercut markets that are struggling to adapt and struggling to respond and stay resilient in spite of the conflict. So I'll come back to that a little bit in terms of implications. So we used 4 main data sets. The first is the rural market monitoring. I'm going to emphasize rural because this does not show kind of the big hub markets in urban centers. Instead, what this does is uses a machine learning algorithm to identify marketplaces throughout Sudan, or actually they're working on a number of other countries in Africa as well. Look for changes over time. So these are markets that will have 1 or 2 operating days during the week. And then going back to 2019, map the change in size and density of that market to essentially show how busy and how active it is. And we see a lot of variation, not only because of the conflict, but because of seasonality shifts and things like that. You know, each market kind of goes through a variety of sizes throughout the year. And then we also used NDVI as a proxy for agricultural production. We used the ACLID conflict database to show specific conflict incidences like battles and violence against civilians. And then we had a data set from NASA looking at precipitation and moisture. So I think the first big question was, to what extent are these markets in Sudan still functioning after the conflict? This first map here is just to show the kind of coverage of rural markets. Transition too fast. The coverage of rural markets, and there are some limitations, particularly in kind of South Kordofan. We think that there's a number of markets that aren't being picked up by the satellites, and then also in the Red Sea and River Nile areas. So it's impossible to ground truth those at the moment, but that is a limitation that's worth taking note of. And then, are markets still functioning? I see Simon. I was hoping that Steve would be here to say, of course they are, you dummy. But I think, you know, kind of in line with a lot of the discussions that have been going on over the last 2 days, these markets are very dynamic, they're very adaptable, and they're continuing with or without support from humanitarian actors. In most of the states throughout Sudan, there was actually a slight growth in rural market size in 2024 compared to the 3 years before the conflict. We see some variation in that. The Red Sea particularly was thrown off by having very few markets. And this doesn't necessarily mean by any means an economic boom, but what we're generally seeing here is that rural markets are often kind of accommodating shifts out of urban centers, which are more targeted by conflict and violence. And then the other noteworthy piece here, I think, is that we see this general trajectory regardless of territorial control. So there's no clear differentiation between SAF or RSF controlled areas. And if we zoom in a little bit, then we can start to see here that some of these specific dynamics. So if we look at North Darfur, this is a state that particularly more recently has been very affected by conflict. And the area around El Fasher especially has been affected by targeted violence against markets. This particular market is actually an urban one in El Fasher. So it had initially hosted a lot of internally displaced peoples and still is, but the markets that are serving them are being specifically targeted. And what we can see is we kind of look at the trends throughout the state is that in spite of these outflows from in spite of these impacts on urban activity, we still see kind of an outflow and a shifting out into the rural areas around that, which tends to lead to some growth and recovery. This is focusing specifically on, you can see the trends here, where even where there are a number of battles and some violence against civilians, there is some recovery in nearby areas afterwards. And that models, we see this a fair amount throughout Darfur, that there's growth in the rural areas, which essentially reflects the shifting of patterns of trade. As we look at some of the safer areas, like initially Al Jazeera and Gadara, we see that they actually grew substantially. So in Al Jazeera, there were, I believe, 450,000 internally displaced people that were there in 2023. And there was a large growth in the rural markets, which accommodated both the increased demand, and then there were also more anecdotally, but a lot of reports of internally displaced people that would begin agriculture as a means of temporarily meeting their needs. We can see in Al Jazeera, violence actually began to pick up more in 2024, and there was a shift down in market size, actually quite a substantial drop. So the growth that we see earlier, of course, went away as there was more intensified conflict. But when we look at some of the other safe states, I'm sorry, I thought I had a picture of Gadara in here. There are a number of safer states in the east, including Gadara, Kassala, and the Nile states, which have remained more stable and have seen growth typically of 40 to 50% in the rural market size. The other advantage of these data sets are that they're longitudinal and they cover the entire nation. So we were also able to look at the relationship between incidences of conflict, market activity, and agricultural activity, and look at how conflict was affecting them, and then controlling for conflict, how changes in market size affect agricultural activity nearby. And I won't get into all of the details, but that also helped reinforce this trend that battles or conflict within 40 kilometers of a market led to a reduction that typically would recover in 3 to 12 months. But at a kind of wider distance, between 80 to 90 kilometers, having a battle is actually associated with growth in the market, which does reflect some of that kind of the very local trade, likely shifting out into the more distant markets. And then the other critical piece, particularly from a sort of anticipatory action lens, is that markets controlling for conflict, when markets are stable or growing, we see more agricultural activity. And the converse is that markets that are shrinking or just exhibit, even if they're not shrinking on average, exhibit increased variability and less predictability, are related to shrinkage in agricultural production nearby. So I'll end just with 3 quick takeaways. The first, these markets are still functioning. They are still adapting. For INGOs, for humanitarian actors, there's a real need to, as much as possible, integrate and consider the needs of local actors, consider adaptations that are being done by traders, and avoid undermining them. The second, these data are somewhat limited, so the fact that markets are still functioning doesn't mean that people are able to access or afford food. And I think it's been raised several times that there are many people who are not going to be included and are going to be marginalized. For those that listened to Margie's session in this morning, there's shift out from traders to kind of military affiliated traders, things like that. So these alone can serve as a strong complement, but should not be taken as a standalone analytical system. And then I think the third is also that these data may serve a future role, and we do hope that they are included more in models of need that are used by, again, humanitarian actors. We can see where there are repeated patterns, and when those start to shift towards negative trends, then it does suggest a need for intervention. And I'll put out quickly as my last point, going a little over time. I think the analysis that we've done is more of a bird's eye view and is not particularly locally informed. And we're hoping in the future that there might be more opportunity to kind of look for specific patterns of trade or test specific assumptions that are more grounded in kind of in-depth reporting, like Margie Buchanan-Smith's and others. So if anybody, you know, has ideas, has questions on how to use this data, please feel free to grab me at lunch or this afternoon. Thanks.
Amazing. Thank you so much, Daniel. It was indeed a very interesting presentation. I could see everybody was waiting what was next.